All right, so a function. What did we say could not repeat yesterday to make something a function? The x's. And remember we said it's not fun to date your x's twice. But do they have to label it as the x coordinate? No, it's just the first value, all right? Okay, so moving on. Now we looked at this yesterday. Remember this is called set notation. You got it? What did we highlight yesterday? We highlighted the x's. And when you highlight the x's, that's the only numbers that you're looking at, correct? Just the domain. So, is the first example a function, yes or no? Yes, why? Because none of the x's repeat. All right, is the second one a function? No, why? Is the third one a function? Why? Do we care at all about the y's? Nope. All right, so choose a number that would make this not a function. Would 7 make it not a function? Either 5 or 3, because it has to repeat in order for it not to be a function. What numbers would make it a function? 7, what else? Right, any number that's not 5 or 3. Okay, cool, moving on. So this was called what? Mapping. And instead of giving it in set notation, they put it in bubbles and draw arrows to it. So just to recap, this means this is the point 2 what? 4, because the arrow goes there. This guy right here is the point what? So what is this point then? 1, 5. This one, 3, 1. All right, but what is the fastest way to tell if this is a function or not? Yes, we look at the lines, right? How many lines can be going just from one number? Just one. So as long as there's only one line coming from each number, is it a function? Yes. So is this one a function? Yes. Is this one a function? Is this one? No, because 1 has how many? 2. Does it matter at all about your range? No. Okay, and this one, yes or no? Yes. All right, so that's our functions. Then we looked at tables. Guess what? It's the same thing for tables. We just highlight the x's, and you just tell me if those repeat or not. So is that example a function? Yes. Is this one going to be a function? Why not? Is this one a function? No. Why? Because of the 10. Is this one a function? No. Why? Because of the 40. All right. Once again, mapping. So is this one going to be a function? No. Why not? What about this guy? Yes. What about this one? Yes. And yesterday I even showed you one that looks like this. Would that be a function? Yes, because all we care about is what's coming from the first set. You got it? Okay. Now the last part of functions was the vertical line test. And which way is the vertical line? Show me with your hands. Yes, it goes up and down. All right. Now this is the part that kind of confuses people, but it shouldn't. How many times can the vertical line hit the graph? Only once. So since Caitlin's here today, let's show her what it looks like not to be a function, because that's easier. So if I drew a vertical line just straight down, everybody count how many times it's going to cross just the blue part of the graph. I do not care about the coordinate grid behind it. You're just talking about the shape of the graph. So everybody count. What is this? 1, 2. It crossed twice, so is that a function? No. All right, what about this guy? 1, 2. No. What about this guy? 1. So is he a function? Yes. Now remember, you can actually draw multiple lines, but if you just draw one, you're good. So it can only cross once. Why can it only cross once? Well, let's talk about that. Because if I was looking at this point, this would be where x is what? -1, right? What would this coordinate be? Where x is still -1. So your x's would repeat. Do you see that? So the shortcut, though, is the vertical line test, and it can only cross once. So let's look at some more. So this guy, if I drew a vertical line, how many times does it cross the graph? 1, 2, 3, 4. So is that function? No. What about this guy? Once. So yes. What about this guy? Yes. This one. This one. No, because twice. This one. No. This one. This one. Yes. This one. No. And look, I did 2 lines, but does that matter? All right. How many here? Yes. Here. And then this guy? No, because it hits more than once. Do you understand? All right, that is functions. Now, this is your linear rules, because remember, functions and linear are 2 separate things. Has everybody got that? So these are your rules in a nutshell. I'm going to give you time to copy them down. So put them in your notes. And if you want, if you're watching the video, you can pause the video and just unpause it whenever you're ready to go. Okay, so linear rules. Something is linear if it makes a straight line. Because the keyword in linear is what? Line. Just like the keyword in functions is fun. Remember? Okay, so something is linear if it makes a straight line. We are going to look at tables, graphs, and equations and determine that. Now remember, this is different rules than a function, right? You have to separate these 2 things from one another. So first, let's look at tables. And for tables, if it was a function, what would we do? Okay, y'all are answering for linear. I just said if it is a function, what do we do? Yeah, function, you would just look at the x coordinates and see if they repeat, right? So would this be a function? Yes. Is this a function? Is this one? Yes. But we want to do linear. So for linear, we got to see if they have the same ratio, the same constant, all right? So from here, and you only do it by adding and subtracting. So 2 plus what will get you to 5? 3. Now the quick way to check is to look at every single number in between here and see, do you always add plus 3? Okay, so far so good. Now you do the same thing with the bottom. So 1 plus what is 3? 2. Awesome. And then are you doing the same thing here? What's 3 plus? Ooh, plus 4. What about 7 and 13? 6. So is that adding the same thing each time? No. So is that linear? No, it is not linear, because in order to be linear, it has to be the same ratio on top and on bottom. All right, so let's do table 2. Yeah, it wouldn't be linear. Good question, Megan. No, it would not be linear. All right, so table 2. Once again, what are we adding for each of these? 1. That's good all the way across. Now let's come here. 10 plus what is 13? What about? So is that the same? No. All right, so let's look right here. For table 3, what am I adding each time? 2. All right, that's good. What about here? And am I adding 5 for each one? Yes, so is this linear? Okay, now let's talk about how the leap can throw a curveball at you real quick. Let's say that the leap actually did not include these 2 points. Let's say that our table went from 816 all the way to 1431. Well, 8 plus what is 14? Plus 6. 16 plus what is 31? 15, okay? All right, so let's look at our 2 numbers. This fraction right here, and normally it's y over x, but it truthfully doesn't matter what you're looking at. You would have 2 over 5, right? Will this reduce to 2 over 5? Yeah, what would we divide both by? 3. So if it can also reduce to the same ratio, then it's still linear. Does that make sense? So they could actually pull out some points from there. So you don't just look and say, oh, but this is plus 6, so no, it's not linear. Make sure that the ratio doesn't reduce to the same first ratio. You get what I'm saying? Yes, no? Get what I'm throwing down? You picking it up? All right. Okay, and then here, there's just some more tables. All right, so that's tables. Graphs for linear is even easier, because what do we just look for if it's linear? Straight line. So who is linear out of this section? Graph. Yep, just that one. Who is linear out of this one? The second one. All the other ones are not linear, but are any of the other ones functions? Yeah. Which ones are functions here? Second's a function. Third one's a function? Yeah. The fifth one and the fourth one. What about functions here? And this one, because it's down here. Now, somebody had asked one, oh, the first one is also a function. Good job. This one is too. Okay, somebody had asked about linear. They said, well, Ms. Fruget, this is two lines connected. But in order for it to be linear, it has to be a constant rate of change. So it's completely linear. Like it's a one straight line. Yeah, one line. All right. So the last thing, and I think this is where we stopped yesterday, is equations. So go ahead, take a second, or did y'all already write this down? Okay, you already wrote it down. Great. All right, we're going to go ahead then and do these equations just on the video, for the video. Whenever we're looking at equations, you have your rules that you copy down at the very beginning of the video. So whenever we're looking at our rules, we want to make sure they have three conditions. The first condition is that there cannot be any exponents besides positive 1. You got it? On the variables. Somebody had asked in 7th hour yesterday, what if it's 4 squared? Well, what does 4 squared equal? 16. 4 squared is 16. So if it's on the number, that's okay. But if it's a variable that has an exponent, it's not okay. You got it? It can only be positive 1. Also, what's the other condition? Who remembers? X can't be on the bottom of the fraction. And what's the other one? X and Y cannot be multiplied together. Good job. Okay, so here, does this one pass all three? Yes, because you don't see an exponent, because it's imaginary, right? It's understood 1. You don't see an exponent. X and Y are not multiplied together, and X is not in the bottom of a fraction. As long as all three things are working okay, then it is linear. So yes, this is linear. Is this one going to be linear? No. Why? Because X and Y are multiplied, so this is not linear. Is this one linear? No. Why not? Because it has an exponent, right? What about this guy? Yes. Why is this one linear? Because it's in the numerator, right? It's not the bottom of the fraction. All right, what about this guy? No, why not? X is on the bottom. All right, let's think of a linear equation. Jade, give me one. Good. Is she right? Does that one pass all the qualifications? All right, Megan, give me another one. Good. All right, someone give me a non-linear equation. Zeth? Good. Why is Zeth not linear? Good. All right, Carly? Why is Carly's not linear? Because she has X on the bottom. All right, Caitlin? That's okay. Bethany? Good. All right, you got one? Tell me. Good. Why is hers not linear? They're multiplied and X is on the bottom. Ooh, she gave 2 of them. Okay, one more and then we're done. Megan? Okay. Oh, why is hers not linear? All 3. Very good. Okay, so any questions about that? Y'all understand about functions and linears? Y'all got it? Okay, we're going to look at some questions now off of Eagle. The same people that make Eagle questions also make your LEAP test. So that's why your LEAP test is important. So Okay, so this is for one of our one of our practice questions. Which diagram models a function? First off, what kind of diagram is this? This is called what? Mapping, right? Okay, raise your hand if you know which one models a function. Just look at them all. Let's look at A. Let's look at B. Let's look at C and D. Which one models a function? Do I need to show you them again? Which one is a function? A, B, C, or D? On three. 1, 2, 3. B. Why? Good. Doesn't repeat. Okay, let's look at number 2. Is this graph a function? Now I like this because it's not connected, right? It's just points. So through each point, that's when you draw your vertical line. So is this one a function? Yes. Why is this graph a function? Because each time you would draw your vertical line, it's only going to hit how many points? 1. Do y'all see that? Yes or no? Okay. Number 3. Oh, we're going to do that later. We're going to do that later. We're going to do that later. All right. What is the equation of Kyle's graph? Who knows that? There's your answer choices. But let's just come here. First off, where do you B starting at? Your B would be what? 0. And then what's your slope? To the right one. So what would it be then? It'd be A, because y equals 3x. Do they have to have the 0 in the back? Nope. Why could you have eliminated B? So it's not linear. Very good. Yes, very good. You couldn't do D either because x was on the bottom, and that's not linear. Go ahead, Bethany. You're on fire. I love it. All right. We're going to do that later. All right. Which relation graph below is also a function? Is A going to be a function? Yes or no? No. Why not? Where at? On the 3, it's not a function, right? Because there's 2 dots on the same one, 2 points. All right. Is B a function? Yes. Is C a function? No, because of what number? The 3 has 2 dots. Is D a function? No, because of what number? Because they're all on -3. Okay, let's look right here. I'm just going to read the question. Which statement best explains whether or not the resulting graph represents a function? Okay, if it wants a function of age, of whatever is what you got to see if it repeats or not. So you're just looking at age. You don't care about price. You got it? So, is it a function of age? No. Why not? Because 1's repeat. So, what would our answer be? Would it be C or D? Why C? Because 2 ages. Because we don't care about prices, correct? All right. Which relation is also a function? Which one of these are a function? On 3. 1, 2, 3. B as in boy. Good job. Okay, we're going to do that later. Do that later. Which relation is also a function? On 3. 1, 2, 3. D as in dog, because none of your x's repeat, right? Which set of ordered pairs represents a function? On 3. 1, 2, 3. Why is it A? Good. Okay, we'll do that later. Which graph is not a function? give you all your choices. Which one is it? A. Notice, you see how it says of x? That just means your x's can't repeat. That's why it's a function of x. Alright, look at that later. There's one more that I want to show you. This one. What does this bold word say right here? So this could have more than one answer. Which equation is not a linear function? So we're going to go through all of them and you're going to tell me yes or no. Would A be yes or no? So A is a linear function? No, it's not a linear function because x and y are multiplied. What about this one? That is linear. What about this one? Yes, that's linear. What about this one? What about this one? What about this one? What makes this one not linear? Okay, let's look at the rest. Which ordered pair could be added to the set such that the set would still be a function? To still make it a function. Select each answer. Zeth, give me one answer. He says maybe A. Is A correct? No, because then 1/4 would be repeating because it already has 1/4. Caitlin, give me one answer. D, why 0, 0? Because there's not a 0 already for your x. All right, give me another answer, Jaden. D, why D? There's no positive 1/3 already as your x. And Megan, last one. F, why F? Very good. Okay. Parker states that any function written without exponents must be linear. Which function proves Parker's statement is incorrect? So Parker's thinking only variables that don't have exponents, it's linear. That's the only condition. But there's other conditions, right? So which one makes his statement incorrect? Select each correct function without exponents. Okay, what's one of them, Caitlin? D, right? Because it's the denominator. And then what's the other one going to be? Megan? E, because they're what? How come we wouldn't answer B here? Because it's telling you without exponents. Yeah, so that's backing up his opinion. You're right. So since that's his opinion, it's only these two. Okay, let's look at our last two. Nope, nope. All right. Select all of the following that are linear. That are linear. Is A going to be linear? No. Is B? Why not? And what does x times x equal? X squared. Y'all remember that? So nope. What about C? Yes. What about D? Why not? What about E? Why would this one be linear? Good. How would we graph E? Yes, distribute, and then you figure out your slope and your y-intercept. Good. Okay, and then F? Yes, because you're not multiplying the x's. You could combine the like terms, and you would get y equals 5x plus 7. Y'all got that? Okay. Yay.